Hello, let's have a look at contexts within Gaffer. Now, before jumping into Gaffer directly, what I would recommend doing is going to the Gaffer documentation. Under working with the node graph, you have a context section, and this really nicely goes into detail about what contexts are and how they can be used alongside some visual examples, which I think is the best introduction to get started with them in the first place. Then if you want to have a look at some practical examples, we can go to Cinesite, Shared Notes, and load the Wikidemo contexts file. Now, contexts exist mainly in two different ways that you are most likely going to interact with them inside Gaffer. One being custom contexts that you can create and modify and manage yourself, and good example for this is in a multi-shot environment. You might want to use them to dynamically switch the node graph based on the shot, or to do overrides only on a specific render layer, for example. And there's also the other way of using the Gaffer built-in contexts, and there's a variety available, such as the current frame number, for example, or the current path to query from the hierarchy view. Now, using custom context variables is from a concept very similar to using graph state variables inside Katana, also because you can set them either globally for the whole scene, or you can set them locally only for the graph. Now, in this case, we have 3 lights, and let's say we wanted to switch them based off of a context. We can do this with a name switch node, connect them all up. You can see that the selector at the moment is a Cinesite preset of scene and shot by default. Now, this is useful for a multi-shot environment, and we have a couple of other defaults available as well. However, what we want to do is we want to specify a custom context variable. Now, once I do that, you can see that it uses the value that I had previously set as the custom input here, and you can see that the context variables here, scene and shot, are queried by putting them in curly braces and prepending them with a $sign. And this is the way to query context variables within regular string plugs. There are also plugs available on certain nodes inside Gaffer that can only query context variables in the first place, and in those kind of situations you don't need to wrap them in with this specific syntax, but can just specify the name directly. Now, in this case, we want to create a custom context variable called LGT, for example. And the switch node is going to switch the inputs based on the values of the LGT context variable. And let's say we can specify them manually here. And the first input for the distant light, we want to query if the LGT context variable has the value dist, or if it has the value spot, we want to switch to a spotlight. You can see that at the moment nothing is changing, and the reason why nothing is changing is because the LGT context variable has not been declared anywhere within the script. Now, as I mentioned, we can, for example, declare a context variable globally for the whole script by going to File, Settings, and switching to the Variables tab here. We can add a new variable of type string, because the values that we want to query here are string types. And here we can call, or we can create the context variable directly without wrapping them in curly braces and prepending them with a $sign, because the variables section only accepts variables as names directly anyway. And if we set the value to spot, for example, you can see that the name switch now queries the spotlight input, because this is what is active when the LGT context is set to the value of spot. Likewise, if we were to change this to dist, this is the name switch is now querying the distant light input. If a variable doesn't exist, or if I set it to a value that doesn't exist within the name switch, it will automatically fall back to its default input, which in this case is the quad light. I can right click here and delete the LGT context variable globally, and let's have a look at how we can change it locally within the graph. We can do so by creating a context variables node, and if we view it, we can add a string plug here. Once again, call this LGT and change this to spot, for example, and once again we will switch the name switch now based on this context variables node. However, if I was to set my viewpoint again to the name switch, you can see that now it's falling back to the quad light input. And the reason for this is because the context variable LGT only gets created at this point in the graph when the context variables node is viewed. So as you can see, instead of following the traditional graph flow from top to bottom, context variables information are actually passed upstream. And this is a very important concept to understand, because it can really help you getting to understand how context variables are working and how to use them effectively within your scenes. Now let's have a look at another example. Maybe not the most production related scene, but let's say I have a Gaffer bot and 2 different lights, and let's say I wanted to scale my whole scene for whatever reason by a value of 10, for example. You can see that while this works, the light visualizers in the viewport are not scaling accordingly. So the higher I scale the scene, the harder it is to see where the spotlight is actually shining on the robot. Now what I can do is I can use the OpenGL attributes node to change the scale of the visualizers accordingly as well. And if I was to do that, you can see that now the visualizers are scaled accordingly as well, and it's easy to see everything in context again. Now you could link the scale of the OpenGL attributes and the scale of the scene scale together. However, linking parameters directly has the side effect that if one of the nodes get deleted, you will lose the information. At the same time, in a production scenario, they might be scattered across the Gaffer script inside different boxes. So what we can do instead is we can create a context variable and set the scale based on the value of the context. So to do that, we can right click on a plug and create a context query from here. And this will create a context query node. And let's say we wanted to query the context name scene scale. If scene scale exists, we will use this value, and if scene scale doesn't exist as a context, it will fall back to 1 in this case as the default. Now you can see that this context query node has 2 outputs. One's a boolean to tell us whether it exists as a context variable yet or not, and a secondary output that tells us the value of scene scale. At the moment, because the context variable doesn't exist, it will output a value of 1 because we specified this as the default. We can also use this output value here on our OpenGL attributes scale as well. And now what we can do is we can once again create a context variables node. And we can create this time a float context variable of scene scale. And now if we change it, you can see that both the scene scale and the scale of the visualizers are changing both in tandem. And I can use this context query wherever I want in the scene with as a separate node as well, and everything will change together in tandem. So you could use this, for example, also to scale the intensity of the lights to maintain the look if you scale the scene, for example. Let's have a look at a bit more production-related scene, which is the city attack scene from the Gaffer examples. And here we have two passes, or render layers, as they are called in Cinesite, available. Now, the two layers that I have is once a beauty pass and a volume pass as well. And Cinesite modified the UI of Gaffer slightly to expose the available layers in the scene on the bottom right here as well, to switch between them. And this is quite useful because instead of having different outputs, you can dynamically switch between different layers that you have available. So if I was to launch a render here, you can see that if I switch to the volume layer, that I can now see my pre-set up volume pass. But let's say I wanted to do some overrides on the volume pass. I can once again use a name switch. Connect both inputs up, and let's say I want to use the layer as the selector. And the second input here should be looking at the volume pass. I can now, for example, let's say that I did not like the contrast level and I want to have it a bit higher. I can, for example, prune my skydome light, and at the same time, let's say I want to transform the key light to make the shot a little bit more dramatic. Let's say something like that. And now those two overrides are only active for the volume pass. As you can see, Gaffer nicely does highlight which stream is currently active as well. If I was to switch back to the beauty pass, these two nodes are not active and consequently also don't modify my beauty, but only the volume layer. Now in another example, let's say you have a couple of different lights available and you wanted to randomize their values, for example. What you could do is you can add a shader tweaks node, and instead of modifying all of them in tandem, you can right click on the color and hit randomize. This will create a random node as the input for the color of the spotlights. And you can specify a base color here and a maximum hue, saturation and value offset. This number is or this range of values is chosen as a range to randomize based on the seed. So if I was to change the seed here, every time I change it, it creates a new random output color. Now the thing is that this seed alone is just changing all of the lights in tandem. What I can do instead is make use of Gaffer's built-in context variable, for example the scene path context. And the scene path context will basically give you the paths of the lights as strings, and it is then creating a random seed variable based off of the names. So if I plug in the scene path context inside here, you can see that now each of the lights has a different value because each of the lights has a different unique path in the hierarchy view. I can further change the seed here to give a new randomization. Also, for example, change the maximum range at which I want to vary the lights that I have in the scene here. Let's say that you didn't want to randomize lights, but that you wanted to create some in the first place. What we have here is a set of street lamps, and let's say I wanted to add some lights inside of them. What I could do is I could create a point light, Arnold point light, and parent it to the scene. Now, instead of creating or querying just a single parent, the parent node also has a filter plug as an input. So if I was to take this bulb object in the middle here and use that as the parent, you can see that I created the point light directly underneath it. But let's say to keep the scene a little bit more organized, I didn't want to create it directly under the parent, but under a separate root called LGT. What I can do is I can wildcard my selection here. So I want to get both the left and the right lamps and any of the lamp's children. And if I was to query the result of this, you can see that this is selecting all of the lamp's bulbs, and it's consequently also creating a new light for all of them. At the moment I have 11 of those. Now, if I was to have a look at the lights, you can see that at the moment they are still all at the origin. And the reason for this is that first of all, I'm creating them outside of the group, but also none of the lamps has actual transforms on them, which is very similar to what you will see in the production context. So what I could do is I could create a point constraint node, and let's say I want to apply this to the first light here, and as the target I can set the lamppost centroid here from the first one, and as the target mode origin won't work because we don't have transforms, I can set this to bound center, and you can see that I now created the light inside of the first lamp here. So just make it a little bit bigger to see it easier in the viewport. Now, the issue is that if I was to set it up like this, I would have to create a point constraint node for all of the lights and manually hook them up. And the problem with this is obviously manual labor, but also if the number of lamps was changing, the whole setup wouldn't update dynamically. So what we can do instead is we can take a look at the parent node here, and we have this parent variable plug available. And basically what you can use this for is to basically define a variable name here, and this variable name will pass the parent, the current parent of each of the lights that you are creating upstream. So what we can do is we can take the point constraint node, actually create a new one, directly under the point light, point constraint, and here we can first of all have to specify to operate it on the point light, and as the target we can query the parent variable that we have just created. Now at the moment you will see that this is throwing an error, and you can see the error if you hover over the error. It's basically saying that this particular parent, which is the centroid of the first lamppost, does not exist at this location, which is very true, because if you're viewing at this point in the graph, the lampposts don't exist. But the point constraint luckily comes with a target scene, which you can plug in here to specify where the constraint targets are living. And now the point constraint is not erroring anymore, and we just have to set it once again to bound center. And you can see that now with just a few nodes in the scene, we are dynamically creating a constraint, and we are copying the lights over to all of the lampposts here. This is also very useful if you were to change the number of lamps, for example. If you get more or less, you can see that this is dynamically updating here, no matter how many lights we have in the scene. As a last example that is probably also useful to know in a production context is one thing, without going too much into detail about what the collect scenes node does. It's often found inside of the bundle loaders inside of Gaffer. Now basically what we're doing here is we have just one scene reader node, and based on the context we are looking up the paths for these root names, average Joe, scale man and scale woman, and query the file names here. Now inside of the bundle loaders oftentimes these are hooked up to more complex expressions, and it's not that easy to see which caches are loaded in the first place, because the scene reader here is blank, as it is only queried once we create the context for those root names. Now if you want to debug what is actually being loaded, what you can do is you can set the collect root name variable, which it's using to query its inputs, in the globals, for example to scaleman, and you can see that now only this input is loaded. And you can also see at the same time the resolved path in the file name of the scene reader here. And this can be quite useful if you want to debug your scene, if one of your inputs is broken or doesn't exist and you want to find out which cache exactly it is. That can be quite useful to use it as well. Lolo. Let's have a look at spreadsheets in Gaffer. For this, we are going to load from the shared nodes the wiki demo spreadsheet scene. And here we have a fairly standard multi-shot setup where we have 3 shots available, which we can switch between. In the set shot node, you can switch between shot 10, 20, and 30. And at the moment, all of these individual shots have specific overrides for sampling settings and the resolution. Now, where spreadsheets come in very handy is to reduce clutter and unnecessarily duplicated nodes. If you have the same set of nodes, but you want to vary them, for example, based on a context, you can do it with a spreadsheet, and this will come with the benefit that you have less nodes that you need to use and a much better overview over the settings on those nodes. Because at the moment it is quite difficult if we want to see which shot has which sampling settings. We need to either switch to the shot or inspect the individual nodes to get an overview over those individual settings. Now let's set up a spreadsheet. We can delete the name switch, which we use to switch between the different settings based on the shot. We are going to set it up with a spreadsheet now. To set up a spreadsheet, you can right click on any plug and go create spreadsheet. This will create a spreadsheet node, and you can see that already it kind of gives you a sort of rows and columns view. We can add more plugs at any point. So let's say we also want to add diffuse and specular samples. We can right click and add it to the existing spreadsheet here. And same for the specular samples. You can see that they all appear here. Let's say I also want to override the render resolution. I can add that to the spreadsheet as well. Now we have those 4 values. The next thing that we need to decide on is what we want to switch based on. In this case, I know that I want to switch between different render settings based on the shot. So in the selector, I can set this to the shot context. And now with the selector set, it will check if there are any matching values in the rows that are set to a valid shot context. So I can, for example, create a row for shot 10, create one for shot 20, and I can create another one for shot 30. And now what I can do is I can do overrides for these individual shots. The selector will check if currently, for example, I'm in shot 30, and it will choose the corresponding values that I set here. So let's say shot 30, for example, is in an earlier stage. I can set my AA samples to 3 and also lower my indirect samples here. And let's say I also want to render at a lower resolution. I can do that here, and you can see now that everything updates accordingly. One caveat though is, as you can see, the linked plug values don't always update reliably. And the better way to check if everything arrives as you would expect is to check in the scene inspector, in the globus in this case, if the overrides arrive accordingly. But in this case, we can see that we have the overrides set for shot 30, for example. And let's say I also want to lower my sampling a little bit for shot 20. And now when I switch between the different shots, you can see that the individual overrides that I set here apply to the matching columns. This gives you a quite nice overview over which shots have which sampling settings. Now, the matching is depending on, goes basically from top to bottom. So let's say I would override the top shot here, or the top entry, to match all of the shots. Basically now this column would override anything that is below it. So now you can see that, for example, even though we have a valid override for shot 30, which we are currently in, and we have the resolution set at 1280 by 720, we're still rendering at full HD because the first match that occurs in the spreadsheet is the first row here, which is set to full HD. So it's always something you want to be aware of. We can also disable and enable individual overrides. So for example, if I wanted to disable all of the overrides for shot 30, I can do that here. And now what basically happens is that if there's no valid match, in this case for the shot, it will fall back to the default values on the top here. I can also override or disable the override of individual values. So I could, for example, enable or disable the resolution update here, and you can see that this only overrides or disables the render resolution for this particular shot, but my AA samples, for example, are still at 3. To clean up the UI a little bit, you can rename any of the columns here. So you can right click and change the label. Let's say we shorten this a little bit, set it to AA, div, spec, and the last one just to resolution. We can also resize those columns a little bit to give us a bit more space to work with. And also, if you at one point have a very long list of columns, you can also divide it into different sections. So for example, what we could do is we can right click on resolution and move it to a new section and call that, for example, let's say render settings, and the rest of the sampling specific sections we can move to a new section and call that sampling settings, for example. And we can move all of the other sampling settings to this section as well. Now we have a bit of a nicer divided UI between different settings, which comes in especially handy, like I said, if you have a very long list of values. Now, spreadsheets can be used, this is the most common thing that they could be used for, but we can also make overrides to any sort of plugs. And let's say, for example, we wanted to adjust the layers that we have in the scene. At the moment, we have 3 different layers. We have a character layer, an environment layer, and a volume layer. However, you can see that at the moment there's no visibility set up for any of those layers. Now what we can do is we can also set that up with a spreadsheet, because once again, what you usually want to do in between as overrides for individual render layers is to set what is visible, what is maybe matte, and what you might want to prune and remove completely from the scene. So let's create an Arnold attributes node. And on this one, we are going to override the camera visibility and set it to off, and we can call this canvas off. And we want to create another Arnold attributes node for setting objects to matte, for example. Under shading, enable matte, and we call this matte. And let's also create a prune node. Now, those 3 different visibility sets, I want to override what is coming into the filter on a per shot basis. Now, in this scene, we have a couple of sets available, so I want to make use of those. If I go to the globals under sets, we do have an environment set, which holds all the environment. We have a set for the Gaffer bot, and we also have a set for the volume box that creates this atmosphere fog. So I'm gonna create a set filter for all of these. And at the moment the sets are empty, so none of these nodes is going to apply to anything. But what I basically want to do now is override what is invisible to a camera, what is matte, and what gets pruned on a per layer basis. What I can do is I can create a spreadsheet based on the sets. I can right click on the first set filter here and create a new spreadsheet. And I want to set the label on this first one here to cam off. On the second one, on the second set filter, I also want to add it to a spreadsheet. In this case, it might be a good idea to name them. Layer overrides spreadsheet. And we set the label to that. And the third one for the prune, we also want to add it to the spreadsheet and set the label to prune. Now what we want to switch based off of is the layer in this case. So starting with the first layer that we want to set up, let's go with the character pass. The selector is layer, so now in my rows I can input the layer names that I want to match to. So let's say I'm going for Char Beauty. Here what I want to do is I want to disable the camera visibility of the environment pass. So I can right click, and in my sets I have my environment set that I can turn off here. Now you can see the buildings are no longer visible to camera. And for efficiency's sake, let's say I want to prune the volume box. Now you can see that the only thing that's left visible is in my character pass is the character itself. I can see that also if I was to switch to a different shot. You can see that this applies to all of the shots that I have in my scene. Now let's next set up the environment pass. I'm going to add a new row for the env beauty, and in the cam off I want to add my character. And once again I would like to prune my volume box for efficiency's sake. And lastly, let's do an override for the volume pass. And in here I don't really want to prune anything, but I want to set everything, all the geometry, to matte. And what I can do here is basically I can, for example, make use of wildcards that I would like to set everything to matte except for the volume sets that I have in the scene. And now basically everything that all the sets that I have except for the volume are set to matte, which is basically all the geometry. Now you can see that all of my shots have consistent passes set up with the same visibility flags. Let's have a look at a bit more advanced use case for spreadsheets. And let's say I wanted to do some overrides on the lights in my scene. Let's switch back to shot 30. I basically have three light groups in my scene. I have light group A, B, and C. And let's say I wanted to do some overrides on those light groups. And I might be in a situation, in this case it's quite simple. I just have 4 lights and it's quite self-explanatory what they are doing. But let's say it was a bit more complicated scene, and instead of doing overrides via shader tweaks node on individual lights, I want to do overrides based on the light groups that the individual lights are contained in, which is similar to the light board that we used to have at Trickster. So let's add a shader tweaks node. And I'm going to let it affect all of the lights. And I want to add some Arnold light overrides. For example, for the color. Which I'm going to leave at 1. And for the exposure, which I'm going to leave at 0 as a default. So you can see that at the moment some of the values are changing because I'm replacing them at the right now, but I want to set the color mode to multiply, so I'm just multiplying the existing color by 1, and I'm adding 0 to the existing exposure, which should leave all of the values at default. Now, to set up the tweaks based on the light group, what I can do is I can make use of the shader query node. Now, inside of the shader query node, we can, as the name implies, query the shader of selected locations. So let's say I added the sky dome light inside here, and I can choose to query a light specific plug, for example the AOV, and I set my fallback to an empty string basically. I can now see that this will query the AOV plug from the sky dome light. In this case, this plug exists and it outputs the value A. You can see that if I was to change this to the distant light, we output B, and on the eye lights we output C. Now, if I was to do this in this way, we can only query from a specific location. However, we can query this dynamically by using the scene path context. And what this will basically do is it will query the AOV from any lights that it might be interacting with. And we can now hook up a spreadsheet that is driven by the light group AOV. To do this, in the shader tweak, we can create a spreadsheet from here. And we also add the exposure. And now in the selector, so far we always specified a context. However, in this case, what we want to do is we want to drive it based on the value for the light AOV that is output from the shader query. So we're just going to link the value to the selector of the spreadsheet node. And now our defaults basically don't change anything. However, if I was to, for example, do an override on light group A, and I was to make it red, you can see that now everything that is included in light group A will get a reddish tint. And we can, for example, also make it brighter. And you can see that this only affects light group A. You can also, for example, do another override on light group C, which are the highlights. And let's say we instead wanted to make them green. And also quite a bit brighter, just for demonstration purposes. You can see that now both of these lights have overrides, and these would dynamically update if we, for example, at a later point added more lights in any of those light groups. Started, good. And then I also started here. Cool. So first of all, let's have a look at regular box nodes. You might be, you have used them now a little bit already if you work with the LookDev template or created your own scenes. It's relatively straightforward. I'm just going to create a simple example here, just of an Arnold options node and a standard options node. And if I want to box them up, ideally, what I would recommend you to do if you want to box up nodes, you should have them connected to an input and an output. That way, when you box them up, the inputs and outputs get connected automatically for you. If I do this, you can see now I have a box node. If I go inside here, you can see everything is connected already. And I want to just quickly go over a little bit of the basics. The first thing I think that is very easy to get tripped up on is by default, if I want to try and disable this node, this box node, it's basically not possible. And the reason for this is because in Gaffer, there's no standardized way of telling this node what should be disabled internally. What you have to do is you have to set up how the internals are being bypassed manually. If you're looking inside here on the out plug, you see you have a pass-through here. And as soon as I connect this, you will see that now I also have an enabled plug on the box node itself. I have it connected versus unconnected. Now, this is usually one of the first things that I do when I set up a box node, because now you can enable and disable the node here. And what I personally like to do is if you hold down Control and you click on the pass-through connection, you can create a dot node, and you can right-click on it and disable show input connections. And now this way, you don't have unnecessary noodles across the board, and you can work a little bit more cleanly as well. As for promoting parameters to the top, you can see that at the moment, this settings tab on the box node itself is empty. I'm just going to open that here on the side. And I can now populate, let's say I wanted to create a tool that has some of the common Arnold sampling options or rendering options, for example, available. There's two ways of promoting or setting up a user interface. One is to right-click. So if I enable the bucket size, for example, I can right-click on the plug and say promote to box, or promote value and switch to box. Promote to box will basically just expose this plug itself. And you can, use the right one, promote to box. You can see now it's just the value, and it's always enabled. What you can also do, however, is you can right-click and say promote value and switch to box. And now this way you can see that you also have the enable and disable plug available for the plugs that have this in the first place. And this is like in Katana if you are setting a local override on any plug. Alternatively, you can also click this little plus here and create your own UI. You have, the usual data types. Bool is basically just a checkbox. You have floats, integer strings. These ones are all vectors. The first one is a 2-vector that just accepts integers. So you can see that now I have 2 values available. And this one could be, for example, used for resolution because you're never going to have 1920.5. You always have full integers available. You can also have the same thing, for example, 3-vector float. And this could be, for example, for transforms as well. Now, when you create them on the node itself, you can see that they are not linked to anything. This is just available in the UI here. What you can do is, I, for example, wanted to manually create one and link it to one of the contents here. I can create a Boolean node here, and then on the name, drag and drop it onto the child node here, for example. And now you can see that if I use this bool plug, it's enabling and disabling the parallel node init plug as well. Now, I'm also just gonna promote this threads here. And you can see that, if you have it like this, the names are not the greatest because it's going to, for example, on the ones where you only promoted the value, it's also going to add value at the end, and it has a bit of a, not very nicely formatted name. You can double click on any of those and change the display name this way. So the first one, for example, bucket size, and rename the other ones as well. However I would want to do it, for example. If you want to have a little bit more control over the UI here, you can go on this little cogwheel at the top right here and say Edit UI. And what this will basically give you is a little description of the node. So this is what you will get if you hover over the node itself, the node name, documentation, and the custom icon that you might want to set. And under plugs, you have all of the plugs available that we just exposed. You can see you have a name and a label for all of them. So, for example, here, if I wanted to have the name without any underscores on the parallel node in it, I can set it up like this. You can see that the plug itself still has the underscore with it inside of it, but the display name is what you basically have in the label. Description is the tooltip. I hover over it, you can see that you have the tooltips available this way. And you can also change the widget, for example. So let's say for the threads, for example, instead of putting in some values here, I can change the widget here to, for example, a presets menu. And this way you can see I get a drop down here. And on the drop-down, I can add options as well. Cannot start preset names with numbers, so they always have to start. They always have to start with letters. So this is for setting the threads. If I want to have all cores, for example, available, I want to use one. I want to reserve 1 core for my machine, or I want to reserve 2 cores for my machine. I can have a nice UI here that relatively easily tells an artist what I want to display here. Now, also under widget settings, you have the option for presets menus to allow custom values. I know it's a little bit cut off here, but it's basically the full name is allow custom values. And what this will give you the option is you can see that now we have a custom input here, and I can enter my own custom value if it's not contained within the preset menu, which I think is quite a nice option. You also have option of adding a divider. You can see you have, I'm not sure how well it comes across on the shared screen, but it basically adds a little divider line to visually differentiate the elements in the UI a little bit. And you can also see that in the graph editor, basically what happens when you promote a plug via right-clicking, it will also most of the time add an input on the node itself. And you can see that, we have those available here, but it doesn't really make that much sense because you don't really most of the time you wouldn't directly connect other nodes inside here. So you also have the option for all of these on the gadget to set this to none. And this will basically remove those input plugs here. And this one. You can see now it's a little bit cleaner again. Cinesite in particular also has a way of cleaning up the UI a little bit because you also have these plug creators, but it's not really that straightforward to create plugs directly from the UI here. So you can also right click and uncheck the plug creators here, and that way it will, get rid of all of them and you have a nice clean UI available for you as well. So that's just a little bit of the basics for it. Regarding what I mentioned earlier, we also have the option to export this node as a file on disk that we can then read in. And this is going to be very similar to Katana live groups. So if I go on the little cogwheel here, I can say export reference. And it's going to tell me, hey, you modified some of the values here from their defaults, and those won't be saved. So if I'm, for example, sure that I want to set a couple of specific defaults, what you can see that they have been modified by this little green indicator at the front here. I can reset the UI to tell Gaffer that, hey, on this node particularly, this bucket scanning enabled and set to spiral should be my default. I can right-click on the node, on the value, and I can say reset default value. And what this will do is you can see that now the little green dot is gone, and this is now my new default. I can do the same thing on this one here, for example, reset default value, and now this would be my default. I can now go again, export reference, and I already have a test export here. I can just overwrite this one. And now if I create a reference node, it's going to open a file browser immediately, and I can just specify exactly that node. And you can see that now I basically have a path to the file on disk. And it's pretty much the same as before, with the main difference being that now inside here, I cannot edit anything because this node is read live from disk. And this can be quite a nice way of sharing tools and so on, because here on the right, I'm still inside the original box node. If I wanted to change anything inside here, I can do whatever I want. But the one on the left, which is my reference, all the contents are locked. Now, because we don't have that much time left, I'm gonna quickly start going over some hopefully more practical examples of setting up a scene like this, where we're gonna go into a bit of detail how we can create boxes with nice user interfaces and custom tools for other users. Now for this, if you want to try it yourself, I have in my shared tools under Trickster, I do have Wiki Light Challenge Base, which is basically a very stripped down version of it. And we can go over and look how we can set up some of these tools ourselves. Now, the first one that I wanted to bring up is creating a nice selector for different images that we might have available for mapping onto quad lights. So what we can do for this one here is a simple quad light mapped with an image, but I don't necessarily want to browse through the published images that are in FTrack here, but I want to have a nice drop-down menu where I can select from them. So in this case, I'm just going to box this one up, label plug creators, and I want to promote this file name here. Box. And you can see it now. I have it available here. However, I want to, like I mentioned, I wanted to have a bit of a nicer UI available for it. So on the file name, I want to change it from a file chooser to a presets menu. And then I can basically add the different files that I had available. In this case, I think, no, I did not save it. Let's say those are four of my files that I want the user to choose from. I can add a new preset here and go for paste the first one here, add a new preset, paste the second one here, add a new preset, third one here, and fourth one here as well. Now, what I do have available is these presets here. Obviously, I want to name them a little bit nicer. So I'm just gonna steal the names here and paste them over manually. And what this will do is it will change the display name. User, and the last one. Now, basically, I can choose between the different images that are available with a nice UI, and you can see that if I change them here, they will output or pass on the according file names to the file name internally of the image. Obviously, I can give it a nicer name. For example, and then I can choose from that here. Let's say we can go one step further and have a look at how we can load as files. Now, I had to look this up myself because I wasn't sure, but basically you can load as files from Arnold in Gaffer via the external procedural node. And what you will be able to specify here is a name. So this will be the name in the hierarchy. And you just have to give it a file name here, where it's basically pointing to the as file that you have. Now, what I basically did is I extracted a couple of the assets from Grow, which is 3 characters, one's with hair and one's without hair, just to have different options available. And let's say I wanted to create a nice UI for that. What I can do is I can box this up once again, label plug creators side. And what I want to do is I want to switch the file name here and accordingly also rename it so that when I load Kamala no hair, it's going to be called Kamala and so on. So what I can do is I can make use of a spreadsheet in this case, for example, because I have the same node. I want to switch just different plug values between them. So I can right click and I can create a new spreadsheet from this one. And I can also right click on the name because that's what I want to change in accordance and also add it to the same spreadsheet here. And I can create my own custom context and call this asset, for example. Go inside here and create a context variables node where I can switch my context. I'm gonna change this to add a string context, create a new context called asset. And I'm gonna reset the defaults to, okay, like this. And if my asset context is called Kamala no hair, for example, I want to load this as file and I want the name to be Kamala, for example. See that if I plug this in here now, I will load the corresponding asset. Now, one thing that I should mention, what's important is that as files are not displayable in OpenGL. You have to actually switch to the Arnold view for that. You can just leave it all on default settings. That way you still have a quite quick response time, even if it's a bit more heavy than OpenGL. So I'm going to add the other ones as well. So I'm just going to add Kamala, which is the same path, just without the no hair. And I'm going to keep the same name. In this case, I'm going to add Monica. I'm going to add Monica no hair. I'm going to add Captain Marvel. And I'm going to add no. Now what I can do is I can basically relate this with the corresponding file paths. And I will probably make a mistake somewhere. And Captain Marvel now here. Now we only need to rename the nodes. Monica. Right.
Just the Monica no hair and Monica are probably like interchanged, but I think we can.
Yes. See, I told you I would make a mistake. Let's just pretend you didn't spot this, Kishore. And everything was going flawless.
It was not recorded.
Yes, exactly. But yes, what you can basically do then is expose that to the box on top here. And here, obviously, this default doesn't make a lot of sense. So once again, I'm going to choose a preset menu. In this case, because I think you got the idea, I'm just going to add the first few ones. Without hair, for example, I'm going to add Kamala. This will then basically switch the context inside. I will just stop at Kamala here and not add the rest of the characters because I hope the idea is relatively clear. And now, we can rename this maybe nicely assets. Then you can basically switch between the different ones that are available. And one last thing that I will do, just to prove the point, if I add Monica, we'll see that it will also change the name of the hierarchy when I add Monica. And of course, I totally didn't mix up Monica with and without here. But this is just to show that you can create nice tools like this in combination with Spreadsheet as well. And the last thing that I wanted to show, which hopefully gives a nice and brief introduction to expressions as well, is a simple plate loader for the images that we have available. All the images that we have are inside this movie refs folder. And ideally, I would also like to have a UI where the user can just switch based on them. You can see I always have the movie name, the number, if we have multiple ones from the same movie available. And the clean ones are basically the background images. So I'm just going to copy one of them. And in Gaffer, you also have a nice 2D user interface. I'm just going to plop in that first one. And if I want to load the clean one, I'm just going to add _clean at the end. So what I could do if I was to box this up is, I could go in again and work with a spreadsheet. I could basically have one image read for the main plate and one image read for the clean plate. Add another box out. And then I can basically choose which one I want to output. I'm just going to call this clean and this one plate. And you can see that now I have two outputs, plate and clean. Now, I want to, however, if I was to create, a spreadsheet for both of them, I would basically kind of have to do the same work twice because I would need to add this to the spreadsheet and I would need to add this to the spreadsheet. And whenever you add manual things, especially let's imagine we have 100 different images available, it's going to be quite tricky to set this up without any human error. You already saw in the spreadsheet above, I made a mistake for the Monica hair versus no hair. So in this case, I want to try and be a little bit of extra safe and set it up with an expression instead. Now, expressions, I'm just going to give a simple overview. You can basically create by right-clicking on any plug and saying create either Python expression or an OSL expression. The difference between them is obviously syntax. Also, there is a little bit of a consideration. Python is usually a little bit easier to use and to work with and to understand. And Cinesite actually has a lot of nice modules to also access ftrack and all of that stuff. However, OSL is a lot faster. So if you feel up for a challenge, you can get a little bit into OSL. However, for most of the stuff that you are probably going to do, Python is going to be a little bit easier to work with. I can right click here and say create OSL expression. Python expression. And you can see that this created a expression node here. And I can basically see that it's setting our node options, the name of the node, and then the path to the attribute. So this is options.bucketSize.value. And you can see there in Python, this is basically represented as a list. You can see that I'm basically just setting the path to that and setting the value here. If I was to change that value, you can see that it updates. And this can be used, for example, to also drive another parameter. So if, just as an example, if I wanted to be the threads to always be half of the bucket size, what I could do is I can drag and drop the name threads here into the expression, and you can see it will give you the resolved path for it. And what I can do is I can specify the bucket size here as a variable. Bucket size equals, and then whatever value the bucket size is here. And I can set the path to, for example, be half of that. Yeah, sorry. Thank you, Alex. They're represented as dictionaries inside Python, the expressions. I can, for example, set the bucket size to be the same. Sorry, I can set the threads to be the same as the bucket size here. I have to say that I want to specify the value. See that now, whenever I change value, threads will change accordingly. But I could, for example, also divide this by 2 or do any sort of math operations, for example. And you can see now threads is always half of the bucket size. And there's obviously a lot that you can do with expressions. I won't go too much into detail because I understand also some of you are more inclined to use it than others. But I just wanted to bring it up as an example because we can quite nicely use them here. So, for example, what I can do on my box node, I can add string parameter or string plug, and I can set it to any of those main names here, for example. So let's say I'm just going to set this to Ex Machina 01. I can then go inside, and now I want to basically have a way of driving my image readers with that. What I can do is I can add an expression node, or I can right-click on the file name here and create a Python expression. And the first thing that I can set is my base path, because I know that they all work, or that all of the images are inside the same directory. So I'm just going to specify the directory here. Then next, I'm going to grab this string plug here. I should probably rename this to ref, for example. I can drag and drop that in here as well. And call this also ref. Now, basically, I created 2 variables, the directory and the name of the reference image that I want to load. And now, on the image reader, I want to set the file name based on those 2. I could drag and drop the file name inside here, and I can set this to base directory plus ref, and then plus the extension .exam. You can see that now I loaded the image here, and you can see how this resolves inside of the image reader. It's basically taking the base directory, which is the name of the directory that I specified. It's taking the reference name, just adding both of them together. So it's just going to concatenate that string, and it's going to add the EXR extension here. So now the cool thing is that if I was to load, what else do we have? Skyfall, for example. Skyfall 01, and you can see that we load the corresponding image. We can do the same thing now, because the main reason why we are doing it is to also load the corresponding clean plate at the same time. We can do the same thing here, where we say we want the second image reader. Simply have the same thing, except for that it also has underscore clean at the end of the name. So now basically, if I set this back again, I load the clean plate here, and I load the original plate here. Log, because I misspelled it. 02. Almost. You can see that now we always load the corresponding correct images. And once again, what I can do is I can edit UI here, plugs, plate, and I can once again set it as a presets menu. And sorry, of course it's ref. Presets menu, and I can add a couple of presets here. So we have Ex Machina, we have Docker 02, 02, and let's take one more, and the rest. I hope it's relatively clear. And then we can basically, I think I edited the wrong one. There we go again. Where you do something live. There we go. Slumdog Millionaire, Slumdog Millionaire. And I'm just gonna add one more so that we don't run out of time. Now we can basically choose between the two. And we have both of the outputs available as well. I have the clean one here. I have the original one here. And changing between the two is going to load the corresponding image. Good. So basically what I can then do is I can merge this with our render, because as you saw already in the LookDev template, is that we have quite a lot of nice options to do some 2D tweaks on our renders directly as well. So I can just merge those two together. And I did a test here before. And so now we can basically merge our render, if we have one, on top of our clean plate, and we can choose to have the original plate on top of it. Now, as we are running a little bit out of time, you can see that obviously the camera doesn't make a lot of sense right now, but like in a good cooking show, I already prepared a camera beforehand so that we sort of have the same framing. The main difference now is that the output of this box is currently in HD, but I have a render filter active that reformats the render to half res. So at the moment they don't match. What I can do is I can add another plug onto this box here to read out the resolution and resize the references to always be in sync with the resolution. I can do this with an option query node, which, as the name implies, queries one of the global options. And I can, for example, get the render resolution, and the output is available here. And I can, on my box node, create a new vector to ins plug and call this res, for example. Drag and drop this onto here. So now whenever the resolution is changed on the input, so if I reset this to HD, you can see that now it's going to give me HD as an output resolution here. And I can basically simply add a resize node here and set this to a custom format and just link this the expose plug on top of the node. I think that is important to mention here is that you cannot cross-link from different parts of your scene inside a box. If you want to link any plug inside of the node, that always has to come from the parent. You cannot, for example, link to this resize the output of the option query directly. The plug has to exist on the box node itself. Because this is also a trap that I felt before. I'm going to do the same thing here. So now, basically, we have Kamala here. And if I was to now, for example, enable again, which has a half resolution multiplier, you can see that now they will basically go in sync. And the last thing that I wanted to show, because I know it has been a little bit rambly, but just to give you an example of where what my intention was with this, is if I go to a scene that I tried this with on Friday, we can have a look basically what I intended to do for this kind of challenge. So there's obviously a lot of things that can still be improved with this, but basically what I have here is a scene where I tested if this kind of workflow actually makes sense and if it could be a fun challenge in the first place. And here I just did a simple 3-point lighting for Kamala. Sometimes the Anode reader doesn't load everything correctly, but it's still loading the whole thing. And I did a test with her and just seeing whether that could maybe work out nicely. But just did a quick three-point lighting setup. And I can see maybe it even wants to render. The one thing with those as files, obviously, that they are a little bit heavy. So they take a couple of seconds to load, but I have to say that performance-wise, it's still going reasonably well. If you have a day like this today, where the file server is not on our end, obviously, that's going to be a little bit slower. But what I basically intended to do with this is to just say, hey, okay, can we do this kind of thing, just replicating the lighting that we have from a movie shot, from a shot movie on set, just by ourselves. And I think it could be a cool thing to go with, because we have nice digi-doubles. You can basically switch between them, try whichever one works best for the scene, and just get the creativity a little bit up again. For me personally, the thing that took the longest time is setting up the camera. Because just trying to get similar focal length and similar framing. I'm probably the worst layout artist in existence, so that's the part that is a little bit annoying and takes a bit of time. But I think the lighting part is actually quite fun, and you can see, it's just a simple 3-point kind of lighting setup. In this case, where I think it's a fun challenge to try and match these kind of things. If you want to go ahead and try this for yourself, without going through the hassle of setting up all of these box nodes yourself and putting in wrong values and stuff like this, it's in my shared notes Trickster. This wiki LGT challenge is basically the filled out scene that you can use to start with everything that we just went through. One thing that I think is worth mentioning is something that I added here, because all the still frames that I got from the internet are obviously, compressed JPEGs. I converted them loosely to EXRs that are an ACCG so that we can use them accordingly. The one thing that I think is good to do, because it's not really a compositing challenge, but I think it's good to match that a little bit as well, is I added grade node inside here that you can use to match the black point, basically, because that's something that the usual thing that we usually do in comp, but as we have a nice 2D interface, we can do it here directly. And just maybe a quick tip based on that, what you can do. If I reset this to do this yourself, the grade node is already here, and you can basically just go and view the background, for example, and then just from the viewer, you can drag and drop a certain pixel value onto the lift, for example, and then you have it here. And if you want to edit it afterwards, you can obviously do so as well. But I think this is, the main comp thing that is needed for this kind of thing. But other than that, most of this kind of stuff you can get away with in lighting. And I just tried this one out quickly to see how well it would work in the first place. And yeah, I would say that's it. We even finished on time, which I didn't expect.